I got a great follow-up question on my Anime Sprite Sheets in Phaser 4 video. Someone asked, what happens if your sprite sheet has multiple rows instead of a single row of frames? Will this break anything with your animation setup? That's a great question, and it opens the door to something every Phaser dev should understand. How Phaser reads your animation frames, whether they're from a multi-row sprite sheet, or a texture atlas, or even a single row sprite sheet. In this video, we're going to take a look at how Phaser indexes our frames behind the scenes, what happens with our multi-row sheets and when there's empty tiles on the sprite sheet, and how we can create animations from a texture atlas, and how atlas-based animations work a little bit differently when we load in our atlas texture and our JSON file. So by the end, you'll know exactly why some animations just work and why others don't. When Phaser loads a sprite sheet, it's going to create frames based on our frame width and height we provide to our configuration. Based on that config, it's going to start counting from our top left-hand corner and then start at index 0 and move across our first row. We'll start with 0, 1, 2, 3, and 4, and then Phaser's going to move down to our second row, and then we start at index 5. And so if I load it in the sprite sheet into Phaser, internally, Phaser's going to start counting at our top left-hand corner. We'll be at index 0, then we'll go to 1, 2, 3, and 4. Phaser will then move down to our second row, and we'll be at 5, 6, 7, 8, and 9. And it's going to continue this pattern until we reach the bottom right-hand corner of our sprite sheet. That indexing order is exactly what Phaser uses when you call the generateFrameNumbers or generateFrameNames methods to build your animations. And so in a multi-row sprite sheet like this, where we just have one animation, in order to create our animation, we can use any of our methods that we covered before. So we can use our generateFrameNumbers or generateFrameNames method, and all we need to do is pass in the asset that we want to get our indexes from. Since our sprite sheet is just one continuous animation, we don't have to worry about passing our individual frames. However, if we wanted to, we could pass in our start and end frame, or even an array of our frames and manually specify them. But in this example here, that's not needed. The part that usually causes confusion is when your sprite sheet has empty tiles, maybe used to separate different animations or pad each row to make everything line up nicely. Phaser doesn't skip these empty tiles, it still counts them as valid frame indexes. That means your animation frames might start later than you expect. And so in our example here, this sprite sheet, this could just be one long animation with a gap here that we need to ignore. It could also be two separate animations that we might want to play. And so if we wanted to create our animations, we need to be mindful of that empty space inside our sprite sheet. And so in this example, when Phaser goes to create our indexes, it's going to start on our top left-hand corner. We'll start with 0. We're going to move across our top row until we get to our empty space. And then Phaser's going to assign that frame index 7. So even though it's empty, Phaser's not aware of that. And so we need to account for that when we provide our frame configuration. Then Phaser will come down to our second row, we'll start at the next index, so 8, and it's going to move along until we reach our bottom right hand corner, and so 15. So for this example, if this was just one long continuous animation, and we want to ignore frame 7 and create our animation like this, when we go to create our frame configuration, we need to make sure we ignore that frame. To do that, when we call our generateFrameNumbers method, we'll need to make sure we provide our frame configuration. And so for our one continuous animation, we'll specify our individual frames, but then we omit frame 7, that way that empty frame doesn't show up in our animation. Now if the sprite sheet was meant to have two separate animations, so maybe our first animation is our frame 0 all the way through frame 6, and our second animation is from frame 8 all the way to 15, we can also do that when we create our animation configuration. For that, we'll just specify our start and our end frames for both of those animations. And so to create this animation here, where we play our first animation, we pause, and then after we wait a certain amount of time, we play our second animation. To do that, we just need to create two different animations in our configuration. So for our first animation, we specify that start and end frame. Our second animation, we do the same thing for our bottom row. So the main thing here is when we have these empty tiles and we want to create our animations, we need to make sure we tell Phaser to ignore that index assigned to that tile. Now sometimes, instead of a single sprite sheet, your assets come as a texture atlas. That's a single image containing many different sprites, plus a JSON file that defines where each one is on our image here. This is really common when exporting from tools like Sprite, Texture Packer. So in our example here, this looks like a basic sprite sheet. However, if we take a look at our individual frames, we'll see they're not lined up in the correct order. So if we loaded this as a regular sprite sheet and then try to create our animation with our indexes of our frames, our animation would play out of order. And so for our texture atlas here, if we take a look at our JSON file, we'll see that each of our frames has a unique name. And so we have our first image, our second image, and then in our animation, we jump up to 10. And so we need to tell Phaser how to create our animation based on our file names in this file. And so in our case here, Phaser has a slightly different method, generateFrameNames, because our frames are going to have names instead of our numerical indexes when we load in our texture atlas. So when we use our generateFrameNames method, this allows us to provide a prefix for our file names that are contained in our JSON file, and then our suffix, and then we can specify our indexes of the animation we want to create. So we can still do things like specify a start and end frame, and then when Phaser parses our JSON file, it's going to find our images in the order we specify here. So it's going to start at tile underscore, then our frame we specify, and then our suffix.png. So it'll be tile underscore 0, then it's going to move to tile underscore 1, tile underscore 2, all the way until we get to our end. So Phaser is going to manage grabbing our individual images and pulling them out of our texture atlas, and then creating our animation based on that. So with our configuration like this, we can still create our custom animation and have our frames be in the correct order. So the key difference between our generateFrameNumbers and generateFrameNames methods is our generateFrameNumbers, this is really for sprite sheets where our frames are evenly sized and indexed numerically. generateFrameNames is for atlases where our frames are named individually in the atlas JSON file. Both functions will return a frame array for our animation, but the source data and lookup method will differ. So to recap, multi-row sprite sheets work perfectly fine in Phaser. Empty tiles still count as frame indexes, and we'll want to use generateFrameNames when we work with texture atlases instead of generateFrameNumbers. And remember, Phaser always reads frames from left to right, top to bottom. Once you understand how those systems works, setting up animations, no matter how your artist exports them, becomes super easy. If you found this helpful, hit that like button. It really helps the channel grow. And if you're new here, subscribe for more Phaser 4 tutorials and game dev tips every single week. And if you'd like to support the channel, I've set up a Ko-fi page. Every coffee helps me keep making these deep dive tutorials. See you in the next one.